What's up, dudes? Okay, so we're back. I can feel that caffeine hitting me, boy. It's entering into my veins as we speak. Alright, so yeah, where we are. We're back, 153. Took a little break, went to the gym, blah 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 blah. Took a shower, ate, you know. And here we go. So we had continued testing how to use SQLite and SQLite tests. We were using Claude to assist in that endeavor, and we're gonna pause on that. We're not gonna do that for now. We're gonna switch it up. We're gonna go to please don't show me like that's what made me want to watch the show, but I don't want to see any more spoilers. You know? I'm like, man, I'm gonna be pissed. I've already seen a couple spoilers, and I'm like, yeah, well, that's what made me want to watch the show. Blah 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 blah. That's what I feel like when I hear myself talk. Blah 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 blah. I got 7 problems apparently. Okay. So we're gonna go back to client refactor. We're gonna work on this, all right? Because I like coding. Learning is all right. You know, learning is fine, but coding, finishing this fucking project is really where it's at, right? That's where I really want to be. The burnout on this project is mega. It's massive. It's extraordinary, grandiose. Burnout. Alright, so this is where we stopped, and that's a little bit too much violin there. Save started game local or remote to save file. Okay, so we saved. No, this is what we want to do. We want to save started game local or remote save file. Do we need to do this? Think about this a bit more. Okay, yeah, it's always good to ask yourself, do you really need to do this? All right, so let's just let's start from the tippity top and let's run it through. Okay, we got our wild truth is our outer loop menu screen. We got menu screen little comment here, database setup. Okay, we got our database. We got our cursor. Okay, we got cursor execute pragma journal mode, pragma synchronous normal. Faster. The log to see our settings just to make sure that they are correctly set up like we wanted them to be. Then we have the creation of the table where we create this save data. It's got the object name, primary key, text, and then the value blob there. All right. These are 2 columns: object name and value. Now we do database determines if row at primary key game ID exists. So determines if row at primary key. Cursor execute select exists. Select 1 from say because it returns 1 if it does. If it does exist, it returns 1. That's the proper syntax. Weird. From save data where object name equals game ID, and we don't use double equal to, we just use equal. Now I'm almost certain, yeah, I'm like positive of that actually. I'm not even gonna check that. It's game ID, and we do have this in text format. You know what? I didn't want to do this. I want to just work on it, but I really feel like I need to test this. Need to test this here. This select existing. So I realized I didn't actually I've never used this. I don't really know if this works. You know? I don't think I do. So we'll call this. This is select exists, right? We're gonna go down to select. Okay, and now we'll just make a new little section called select exists test. And so we can do whatever we want. Cursor execute select exists. Select one from save data where object name is equal to game ID. So we're gonna go to the create table and I mean we can just create the table. Alright, so we're gonna create this table. Save data, object name, same exact thing. And then we're gonna I'll just add this in the right here. We'll do say enable table creation below for this to work. And then we do cursor dot execute, and we're gonna do no, so we need to insert into save data values, and we have the, we'll say how you do this one, and then you say comma and it's gonna be the object name as text, so do game ID, and we're gonna do the blob. We could just put 1. I don't really think that's gonna like throw an error. So this should create the table. It should insert into the table this game ID, and that should be the object name. And this specifies it, I think. So we say object name value. Object name value. Okay, so we run this. Oh yeah, we need to print cursor fetch. Let's do fetch 1. So we'll read this file here. Are you running it? Okay, there we go. Oh yeah, and you have to do at index 0. So let me make sure I do that. Yeah, I do that. Oops, almost leave the wrong file there. There you go. Okay, so it's returning 1. Now let's disable the insertion of that, and then let's rerun it. Now we get 0. Okay, so this does work. Yeah, so it returns 0 when we remove the insertion of that row at the game ID or the object name. yeah, so this line select exists, select one from save data where object name is equal to game ID. It does work. Just to verify, we'll re-enable it. Time, give the discount double check. There you go. All right, so it works. We'll say returns 1 if found, 0 if not. Right, I'm gonna go back up to the tippity top, and we can disable that. All right, what's next, baby? All right, so we can get out of this file, and I'll give it the discount double check. Returns, if selected, return 0. Returns 1 if exists, 0 if doesn't. Bam. And verify this exact line works as intended via testing. Okay, so then we got game ID exists, cursor fetch 1 at index 0, correctly have index 0, yeah. And then if game ID exists is equal to 0, that means it's not a reconnect. Okay. So then we say P1 game multiple choice function, P1 game start new game. Alright. And this is correct, so we discount double check that. Game ID exists equals correct fetch 1 0. Yeah, this is also a discount double check. Okay, yeah, we know this works. We can discount double check. I'm adding the discount double check, which is it necessary? Not really. I mean, you know, not really, dude. But it makes me feel good. And we don't want to have the... Oh, shit. You thought you'd never see me again, did you? Gets me every time. It's funny. Okay, then we have else elif game ID exists is equal to 1. That means it is a reconnect, means the game ID has been saved to save file database previously. Alright, so then we do P1 game multiple choice text function. Add in the reconnect to game option. This is a blocking function while true. It draws the window until they make their choice. So then they're going to choose it, it's going to P1 game selection choice is equal to start game. Okay. If they choose to start a new game, then we're going to game multiple choice function. Connect to a remote server or connect to a local machine. So do they want to start on a remote or local? If they connect to a remote server, then we say and connect local equals false. We checked all that. And yeah, because they're not connecting locally, so that's true. That is correctly coded. Client ID, game ID equals get client and game ID, and it is in that order, so that should be correct. I think we tested that. I think we tested that function. I'm pretty sure we tested this. We did. I remember. Yeah, we actually tested it in this file. Client ID, maybe serialized client ID. So we're getting our client and game ID, then we serialize them using pickle dumps because the value is going to be a blob, so we have to serialize it first via pickle dumps, and we use dumps plural, not dump singular, because we dump is for a file object operation, but plural is for just serialization. So we serialize the client ID, passing in the client ID, serialize the game ID, passing in the game ID, baby. And we have a serialized tuple, okay. And then we say cursor execute many. values serialized tuple. Turn to save data values serialized tuple. Huh. Okay. Well, this is because we're not using placeholders. And didn't we say we were gonna use yeah, didn't we say we were gonna use placeholders? I mean, I'll leave this as it is because I know this is like, I know that's trusted. I'm not worried about it. Yeah, there's nothing wrong with that. Should work. Let me say started game local or remote equals remote. Okay, and this is true. Oh wait, this is inserting. Shouldn't we commit right now? We could enable auto commit. We could do that. You know what I'm saying, dog? We could enable auto commit. And that would make it to where we don't have to do an explicit commit after every one of these, because we do want to commit them to the database. And I'm pretty sure this is how this works, right? Look at my man's, look at my man. Why do they always, you know what? SQLite 3 commit. Commit. Just explain this to me. I understand it basically, but you know, there's some gaps. So let's read this. To commit changes to SQLite 3, you need to understand that transactions are a key part of how SQLite handles data modifications. Here's an explanation of how to commit changes. Transactions are used to ensure data integrity. A transaction is a sequence of operations that are executed as a single unit. When you make changes to a database like insert, update, delete operations, those changes are permanent until you commit them. Gotcha. Okay, and then commit the changes to make them permanent. Yes, this is basically just like working with GitHub. You know, like until you make a commit, you know, there's really no solidity to the changes. You know, they're not like, they're not permanent. So SQLite 3 operates in the following transaction modes: auto commit mode, which is the default mode. Each statement is its own transaction. So when we use execute many, well, it's in auto commit mode. I thought auto commit mode was not the default. Didn't it say that? Didn't it say auto commit was not the default? Explicit transaction mode. Begin starts a transaction, commit ends it. I thought auto commit was not the default setting in SQLite 3 via Python. You're absolutely correct, and I apologize for my mistake. Okay. In SQLite 3 Python interface, auto commit mode is not the default setting. Transactions are the default behavior. Within SQLite 3 Python, by default, a transaction is automatically started when you first execute a query that modifies the database. Changes remain in that transaction until you explicitly call concommit to make them permanent. If you don't call commit, changes will be automatically rolled back when the connection is closed. Okay. Now, I got two answers here, so we're going to test this. So let's open up SQLite test. Alright. And what are we doing here? Okay, so we're just, all we need to do is enable the creation of the table. And then we're going to do, we're gonna insert, all right, P1 score, and then basically we're gonna, well, how about this? We'll do insert into. We don't want to do upsert because upsert will avoid the error that would get thrown. We're going to not commit. We're going to insert, and then we're not going to commit. And if auto commit is not enabled, that means when we rerun the file after the first one, when we run it the second time, it should throw an error because it's going to try to, well, no. If auto commit isn't on, then it shouldn't throw the error. It should allow us to insert it again because that means it wasn't actually saved to the database file. Right? Is that correct? I think that's correct. Yeah. If it's not auto committing, then that means when we run this file, well, actually, I know why. I'm an idiot. It's because we had commit enabled. That's why we were getting commits, because I had this commit enabled down here at the bottom. So auto commit is probably not enabled by default. So now when we run this, the only thing that's going to happen, we have creation of the database, the settings, print out the settings, then we have create table, and then we have one insert into save data P1 score. So when we run it the first time, it should run, but fine, but it's not going to commit this insert, which means it's not going to, it's not actually going to save the data to the database. It will get, like, you know, executed to some file, intermediary shit, but it's not going to actually get saved to the actual database file. So that when we run it a second time, there should be no error, and it should allow for another insertion. And that, yeah, that means our understanding of commit is correct, and that auto commit is not. Let's run it again. There you go. We do not get an error. And if we go and look at the database file, well, it's gonna have some shit in here. Yeah, so we don't. But now if we go and re-enable this commit here, then we go back to the tippity top. We don't have to go back to the tippity top. We just run it again. Okay, now it should be committed. Okay, so now if we run it again, now we get that error, and we can verify. We'll delete it. Now we're gonna run it. It's gonna work this time because it committed that insert to the database, this one right here, and then when we rerun it, it's gonna do it again. But it can't because there's a unique constraint failed save data at object name, because object name is the primary key, so there can only be one instance of this object name, and since there's already one instance, that means it has indeed been saved. And again, if we disable the commit and we run it again, okay, well, it actually won't let us execute the command because we are dealing with the database file. But when we run it and then run it again, we can run it as many times as we want because it's not committing. So auto commit is not enabled by default. Auto commit is not the default setting. It's very important. Very important. You have to explicitly call commit on SQLite 3 with Python. You have to explicitly commit. So then bam, now it's committed, and now the second time it's going to throw an error. Boom. Easy. Easy, dude. Alright? You see it. You see it. Alright, baby. Let's get out of this test file. Maybe we can get away from it eventually. You know what? I'll go back over here real quick. I want to put this in a note because I'm gonna forget these things, and just gonna put writing it also will help me remember it. Typing rather. We'll say auto commit is not the default setting. Must explicitly call commit. Yeah, baby. You got it. Alright, what we doing here? Execute many, insert into save file, da 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 da. Boom. Start a game or local. Start a game local or remote equals remote. So this should work. Well. Oh, now this, okay, so this is flawed logic here. Because if we do start, if game, if game ID does exist in the case of else, then it's going to allow us to choose to start a new game. Just because the game ID does exist, that doesn't mean we want to reconnect to that game. We might have got pissed off because we were getting our ass kicked and said, fuck this game, we're out, and just left it. And now we want to start a new game, okay? Well, in that case, we would go here and start a new game. And if we connect it to a remote server, we would get a new client ID and game ID. But, which is fine. But then when we go to execute to insert this data, and do we have to do execute many here? Well, yeah, because we're... Oh, wait, you know what? This is not right. Hold up. There's a couple problems here. So whenever we would try to insert it again, like if it already existed, and then we go to insert here, so we would have to do an upsert. Have to do an insert or update. Called an upsert. So if we try to just do insert, we would get an error, just like we got that error in the test file. The unique constraint would fail because there's already a client ID, game ID saved to this. What we really want to do is say throw away that old client ID and game ID. We're starting a new game. Do that make sense to you, brother? Okay, yes. So this needs to be changed to upsert. Needs to be changed to upsert, since if connecting to new game despite being a reconnect will already have this inserted into DB, causing an error. Yes. So this needs to be upsert, baby. So what we'll do is we're gonna change. Yeah, we'll just go ahead and change this right this second. But we also need to fix this because this is not correct. Each one of these needs to have a name. You feel what I'm saying here, brother? We got the serialized client ID is the actual data. This is going to be the blob, but we need the name as well. So in this case, it's going to be client ID. Right. So we go over here. This one's going to be game ID. Change game. Client ID, serialized client ID, comma, tuple game ID string. Put the comma right there. I had that messed up. Why I did that, dude? Why I did that? Serialized tuple equals bigger tuple containing smaller tuple consisting of the
would cause heart arrest and death.
The object name, isn't that what it's called? Yeah, object name, and then the blob, or aka the value. So yeah, there we go. Now we have the second tuple with the object name and the blob. Now this is correct. So we're going to insert into save data the values, and the two values are going to be contained in that tuple. So it's going to iterate through this tuples, and it's going to, yeah, properly assign, insert this data. So it's going to create a new row. It's going to be row number 1 with those 2 column values, and this is going to be row number 2. And then we, so yeah, this should be correct now, but now we have to change this to upsert. So let's go. Maybe an accidental. Side effect of the drug, baby. Stay away from them. Stay away from the dope. All right. Trust me.
Difficult, but not impossible.
Yeah. So we're doing upsert right here. So we're gonna copy this for the syntax. Now we're gonna insert into save data value, and we can specify. Let's do that so we don't forget what they're called. So we say object name, which is a blob. Then we say values, and then we're just gonna do. I guess we have to do it like this. Question mark. No. It has to be 2. Yeah. Then we're gonna do comma. Nope, that's not right. Close quotes, then comma. So insert into save data object name value. That's the 2 parameters. 2 columns. Values, and these are our placeholders inside of the tuple. And then we have, we don't need this to be an F string anymore. Because, well, string. I think this will work. Oh, nope, this is still not right, because then we have to do on conflict. So we're going to insert into, and then we add on conflict. So if it already exists, if what already exists? Well, the object name. If the object name already exists in the database, then we're going to do update. We do an update. And what are we going to update? Well, we're going to set the value equal to, well, a placeholder. And I don't know if this is correct. I guess we'll find out. Need some water. So how do we do this with execute many? We would have to. Well, I guess we would have to have another like tuple, just like we did here. We would have to have another, call it a value tuple, and that would consist of the serialize client. See, and I'm just like, I don't know. This, I don't know if this is right. I'm just going out on a limb here, guessing basically. So you do update set value equals. Well, wouldn't we do a placeholder there as well? Yes, we would do it like this. And then I totally am guessing. Alright, so we're gonna ask Claude about this. Is this the correct syntax? Trying to update on conflict using execute many. This hip hop meets classical shit. Actually, some of it's okay, alright? Some of it's not. What did Claude say? Oh yeah, I forgot to read this too. And I apologize. SQLite 3 Python interface auto commit mode is not the default setting. Transactions are the default behavior. Let me clarify this. When using SQLite 3 Python SQLite 3 module. Why? Yes, yes, yes. Got it. The syntax you provided isn't quite correct for the execute many method. Let me walk you through the correct approach. When using execute many with an insert or replace pattern in SQLite, you need to make a few adjustments. Your SQL statement structure doesn't match how execute many works. The parameter placeholders need to be aligned with your tuple format. Correct syntax for execute many with on conflict. Insert into save data object name values on conflict with object name. Do update value equals excluded value and then serial. Oh, okay. So you can't. So you can't use a placeholder. The on-conflict clause should use excluded value. Why does it say excluded value rather than a separate parameter placeholder? Serialized tuple should be a list of tuples where each tuple contains exactly two values matching the two. Okay, that's correct. There's no need for a separate value tuple parameter. The excluded value syntax refers to the value that would have been inserted if there wasn't a conflict. It refers to the value that would have been inserted if there wasn't a conflict. If the value that would have been inserted if there wasn't a conflict. Okay, right. So it's just grabbing that same exact data. That is the syntax for that. Okay. And I guess it's excluded because it was excluded from the previous insert attempt call. If your data structure is different and you actually have separate types, you may need to restructure. Got it, got it. Thank you, thank you. So we don't use a placeholder also excluded value refers to the value that would have been inserted on failed attempt due to conflict. You're on the right track, and you asked two excellent questions. Excellent questions, he said. About using a placeholder with do update set equals R. You know you don't use placeholder here when working with XG many. Instead, use excluded dot value, which is a special SQLite. About excluded value, yes, that's exactly right. Excluded value refers to the value that would have been inserted from the it's essentially a new value from your attempted insert. Let me explain in more detail. Single conflict to update, which is SQLite. The excluded table is a special reference to the row that would have been inserted, so excluded value refers to the value from the row. So the excluded table is a special reference to the row that would have been inserted. So excluded dot, oh, okay, so that's your syntax. You say excluded dot column name. Gotcha. Excluded dot column name. I will add this light test that I'm gonna need to add in. So we're gonna copy this right here. And this is gonna be called excluded test. Yes. Okay. So the correct syntax looks like inserting the saved data object name value values. Placeholders on conflict object name update set value equals excluded dot value. Or show that table is a list of tuples. This way, for each pair in your list, if the object name doesn't exist, the term search a new row. If the object name already exists, it updates the existing rows of value you're trying to insert. The beauty of using excluded values is that you don't need a separate placeholder or parameter for the update part. It automatically uses the value from your attention. You know I love efficiency. I am like a Doge fanboy, so efficiency, baby. Let's see the efficient. And I am so sleepy. I don't know why exactly. I mean, I did get 7 hours of sleep, which isn't fantastic, but I just feel sleepy right now. Been sipping on this coffee. Coffee protein drink, and I've smashed half of it, and like I feel the effects of caffeine, but it's not actually making me feel awake. It's just making me feel like anxiety, but I'm still sleepy. I feel like I have anxiety, but I could also fall asleep. Which is not really what you want. Maybe I need sugar. I find sometimes when I'm like this, I need some sugar. I don't like to eat sugar though, because I try to be in shape, you know? Stay away from sugar. Alright, let's get back to it, baby. I just don't like this. I like it. I liked it at one point. I don't like it anymore. This is much better. Alright, so what's this? Go here. And so we need to do insert many. I was on the like, hey, you know, I did a that was a good guess, right? But it wasn't right. So we don't need a placeholder, so we get rid of this. And then we just do update set value equal to excluded dot value, and we don't have to like, we don't have to syntax that, we don't have to f string that. That's just straight up, right? Yeah. Claude said, do update set value, yeah, straight up, boom. So we're just save data object name. Values placeholders on object name. Do updates set value equal to Yep, there you go. And then comma serialized tuple. So this should work now. So let's go ahead and test it, all right? Because we like to test our code. That's what we like to do. We like to test our code. So we try to save data. Blah, 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 serialized tuple. All right, so let's create our serialized tuple here. Serialized. Can we use already serialized data? Serialized data 1. No, we can't use that. Let's do data 4. Well, we're not gonna do that. We'll make our own data here. But is client ID, and then we're gonna do serialized game ID. It's not right either, is it? We need to do need say ID. Just the name. It's the blob. Next one, which consists of game ID is the object name, comma, and then serialized game ID. So now we have to create the serialized client ID and the serialized game ID. Alright. We need a client ID. Then we need a game ID. ID is going to be 2, client ID is going to be. So just say 4. Equals pickle.dumps. And then we're gonna do this copied, except we're gonna use that instead, and then the game ID. There we go. Client ID, game ID, serialized client ID, serialized game ID. Tuple of tuples consisting of the name. Serialized client ID is the blob. So then our second tuple is object name, comma, serialized game ID. Blob. Cursor execute many, insert into save data, object name values, values on conflict. You update set the value equal to excluded value. And then we have a serialized tuple. Pass. Okay, so what we want here is for there to already be there needs to already be a game ID that exists. So what we'll do is we're gonna, well, we'll do both, right? We can do cursor execute. We'll say insert into save data. And we're looking to fill in these columns, object name and value, with the values. Well, with values, well, we have 2 placeholders because there's 2 columns. But then we just do, we want to do a tuple here, and we're going to do the game ID, and then we're going to do the same thing, but this time it's going to be for client ID. And then we want to retrieve the data, so we'll say cursor dot execute select save data, and we want to select save data where name to ID. Client ID first. So select from save data where object name is equal to client ID. So it should return that row. And then if we did print one, it would return that row. Do the same thing, but we're gonna do client ID. I mean game ID. So we have select from save data where object name is equal to game ID. Okay, so let's just go over this. We have our client ID equals 1, our game ID equals 4. We serialize the client ID using PickleDump's client ID. Then we serialize the game ID using PickleDump's game ID. Then we do serialize tuple, which is a tuple of tuples. Then we do cursor execute, insert into the save data table. We have values. Values are going to be the client ID as the object name, and then the value. Okay, and then we do insert into save data. Object name value values game ID. We're doing the same exact thing here. I mean, we're inserting a client ID and a game ID. We're inserting these two rows. And then we're trying to insert those same rows. The only difference is we're using the serialized instead of these tuples right here. So it's gonna do a conflict. It's gonna hit a conflict. The object name already exists in the database. At least it should, unless it only would reach a conflict if it's been committed. So on conflicts if not committed. No, on conflict doesn't have anything to do with whether changes have been committed or not. It's about handling conflicts during the current insert operation. The on conflict clause in SQLite deals with conflicts that arise when you try to insert a row that violates a constraint in the table at the moment of execution. It doesn't relate to uncommitted changes. It doesn't relate to uncommitted changes from a previous statement. So when you execute an insert statement with on conflict, SQLite checks if the insertion would violate any constraints. If there's a conflict, if you're trying to insert a row with an object name that already exists in the table, SQLite follows your instruction and they do update. 5 is the introduction. Transaction aspect is separate. All the changes, inserts and conflict resolution updates remain uncommitted. All changes, both inserts and conflict resolution updates remain uncommitted until you should happen regardless of whether you commit later. On conflict resolves conflicts with data that's already in the database, committed, or with other rows you're trying to insert in the same statement. Is this answering a question that I'm actually asking? So on conflict resolves conflicts with data that's already in the database, or with other rows you're trying to insert in the same statement. Let me clarify. No, I mean if I do insert game ID, then insert client ID, then do and insert Then I do an upsert on conflict game ID and on conflict client ID. Without committing the original inserts prior to the upsert command, will it still consider the command on conflict even though the original inserts weren't committed to the DB? Yes, the onConflict clause will recognize conflicts with uncommitted inserts within the same transaction. This is an important aspect of how transactions work in SQLite. When you perform operations within a transaction, all operations within that transaction can see each other even before. The database maintains a consistent view within the transaction. Constraints are enforced against both committed data and uncommitted data in the current transaction. Gotcha. So in your scenario, we have begin transaction, insert in the table, insert in the table, and then we do in the table on conflict, do update. And the first two inserts have been, so we'll still recognize a conflict with the game ID because it's part of the same transaction. This paper ensures that even within a transaction, you maintain data integrity. If, for example, you were to roll back the transaction instead of committing it, none of the operations would be applied to the database. Gotcha. Okay, cool. Now I know. So let me write this down as a note. Say on conflict will be detected. Will be verified in case of prior insert at same key, despite not being committed yet. Commands within transactions can see each other despite not being committed. Dying over here, bro. I need to go for a walk. I might need some sugar, I don't know. I'm just tired, bro. And the coffee doesn't seem to be doing the trick here. I'm actually gonna go take my break. It's 8 minutes prior, but I'm feeling so sleepy. I'm gonna go take a little break. I'll come back. Be right back. break them. Like, really tired. Like, I get tired, but this is different. So, you might need a little bit. Been out really hard at the gym. Might be a little behind on my intake. Let's see. Let's go over here. Maximize this. Over here, we had client refactor. Okay, so we were testing this. We're getting the correct syntax. Yeah, so this should be the correct syntax. Did we test it? Did we actually test it? I don't think so. Let's see. Where is it? Let's do Control Z. Okay, so let's test this real quick. Then I'm gonna go ahead and call it quits. So we have client ID equals 1, game ID equals 4, serialized client ID, serialized game ID, serialized tuple, insert into table. Okay, and then we try to insert on conflict. It should hit a conflict and update with the excluded value for each one, which would be the serialized client ID and the serialized game ID. And then we do select from saved data, where object name is equal to client ID, and then we print the fetch one. So select that row. Where object name, yeah, alright. And then we do the same thing but with game ID and then fetch it. So let's print it. Here from select, okay, so we have to do select all from. So select all from. And we'll just do select value. That should give us the value column, right? So if we do run this, there we go. Okay, so that got the value column, and it's because it's serialized. So let's do full dot loads, then cursor fetch one, and this will be at index 0. And yes, we'll do the same thing here. Alright, so let's run this again. We're probably going to hit an error because we have to delete the test file. So let's delete that. Let's run this. No such table save data. Did I not enable the creation of it? Yes, I did. That was the table that pre-existed. So let's create that table. There you go. So you get 1 and 4. And let's to those lines. Yeah, so the new client ID was 1 and the new game ID 4. So it previously was client ID was 2 and then game ID was 3. So if it didn't hit that conflict and update it, it would have remained 2 and 3. So if we disable this upsert and delete that file, Wait, what? Oh, byte object not in, right. So in this case, we would do pickle dot loads or dumps 2, and then dumps 3. I don't know if we can do this directly. I've never really used pickle dumps in this way. Why is this? Oh, there you go. Bam. There you go. So now it shows 2 and then 3. But if we do the con, it's in, because it did hit the conflict and it updated the value to be the excluded value for each item in the serialized tuple. So it updated both of them. So yeah, there we go. This works. And we can just put verified works 100%. Yep. So that is the correct syntax. So now we comment this out. We'll just we'll leave this table. So we verified that this does work. So we'll put oh yeah, we can just do our snippet for stopped here. We'll put the date to 17/25, stopped here. Alright, so there we go. Go over here and put our time. So 3:19. So this was an hour and we took a 10-minute break, so back 10 minutes. So we'll say 2:03 to 2:19. So that's an hour and 15 minutes. So then we're at 2.25 hours. We want to do another hour, but I just don't really feel well, honestly. Oh yeah, so that's it for now, guys. I'm gonna go, yeah, maybe I'll come